Hi everyone, welcome to this presentation on inferential statistics. In this video, we shall be discussing the sign test. The sign test is a non-parametric statistical test used to determine if there is significant difference between the median of a sample and and a hypothesized median, or to compare the medians of two related samples. So it's a sample test, a simple test actually, and that is useful when the data cannot be assumed to follow a specific distribution like a normal distribution. So the key characteristics of a sign test is that it is non-parametric, and the sign test does not assume any specific distribution for the data, and it is for median comparison. So it tests the hypothesis about a median of a single sample or difference between the median between two paired samples. So it reduces the data to binary outcomes above or below the median for the analysis. So let's get started with sign test, and we'll see the steps involved in performing the sign test. We'll also see how SciPy in Python can help us do the sign test with just mere couple of lines of code. So the prerequisite for this video or understanding the sign test, some elementary knowledge about Python and basic understanding about probability, the density functions, and the cumulative density and the probability density functions. So sign test, as we discussed, this is a non-parametric test to determine whether there is a significant difference between a median of a distribution. So that means we have a column and all the values here, and the median of this column and a specified value. Either that or the median between two related distributions. That means you have another distribution where the values are related. That means for a particular patient at instance 1 and the same patient at instance 2, and like that you have a paired sample, and in that case also we can use the sign test. So it's pretty useful when the assumptions of normality are not possible in a data set. So why median? Because medians are useful measure when the data is not normally distributed or it's having outlier or extreme values. So median is a measure of a central tendency where that is actually quite robust to outlier and skewed data. Mean, on the other hand, is actually influenced by the extreme values or outlier values. Non-normality is another condition where median would be a better choice. And sign test does not require or does not make any assumption that the data is normally distributed. So first step is to formulate the hypothesis. The hypothesis is the median difference is zero. Alternate hypothesis that the median difference is not zero. So let's say you have a sample of 10 students who took a pre-test and a post-test, and you want to see if the median score improved after the intervention. So like pre-test and a post-test, in between there was some intervention, and you would like to see if the scores are same. Now in this case, the scores before and scores after do not exhibit normal distribution. So we are going to use sign test to conduct that validation. So the hypothesis here is the median difference between the post-test and a pre-test is zero, no difference. That means it's same, right? And the alternate hypothesis would be the median difference is not zero. So first step is to calculate the differences for paired sample. Let's sample one and sample two. We're going to compute the difference between each pair of observation. And for single sample, let's say one sample, and you're going to compare with a particular value, then calculate the difference between each observation and that value. Suppose the differences are 2, 3, minus 1, 4. Just for imaginary case, these are the differences between the values. So what you do now, we will determine the signs. Signs assigns positive if there is a positive difference, and if there is a negative, then it's a negative difference. and ignore the differences of 0 and count the number of positive differences and the negative differences. Suppose the differences are 2, 3, minus 1 and all that. So just compute or find out the positive differences 2, 3, 4, and zeros to be ignored 1 and 2 and so on and so forth. And likewise, we have negative differences minus 1, minus 2, minus 3, and we will also ignore 0 in this case. Count the number of positive differences. Plus is 6, minus is 3. Now we need to make a decision. So first determine the test statistic. The smaller of the differences, n plus n minus would be 3 here. So we're going to use the test statistic of 3. Next, we find out the critical value for the alpha that we have designed for the test. If it is 5%, 0.05, for that 0.05, we will determine the statistic. And that statistic will be compared against the test statistic. Then we make a decision, compare the test statistic with the critical value. If the test statistic is more than the critical value, we will reject the null hypothesis. So the critical value is here alpha is 95%. Essentially, we are saying the number of successes refer to the number of positive signs or negative signs depending on what is minimum. So we need to find out the probability of, let's say we determine in our case, we have determined um, we have taken the n minus as the smaller one. So it will be a negative case. So we will look at 3. So the number of successes will be 3 here. So it will be the number of negative signs, 3. Null hypothesis here, each data point is equally likely. That means either it can be positive or negative. So that's the 50% or zero point 0.5 probability. Now, rejecting or accepting the null hypothesis depends on critical value and the test statistic, and also the same thing you can infer by using a p-value and a 0.05 threshold. Now, this sign test is pretty useful in medical trials, market research, environmental studies, and psychological studies. Wherever we have data which exhibits non-normal distribution and you have a case with outlier data, then you can consider using sign test for either one sample set test or two sample pair test. So limitations of the sign test, there are some limitations of sign test as well. The first limitation is the sign test is only talking about directions. It doesn't talk about um, so it's a limited sensitivity in the sense that it is only limited to positive difference or negative difference. And it is also loss of information because it doesn't consider the magnitude of that difference. It only looks as positive and negative. And assumption of independence is, as in other tests also, this is a limitation here in this case as well. So it's not suitable for multivariate data. It is good for single column data. For multivariate data, we may have to consider another or different technique. And also less efficient with the tied value. If there are tied observations, the observations with the same value, sign test then loses efficiency there. Because it's not about magnitude, it's about the positive and the negative direction. So let's see some examples here, and I'll do this particular problem in in Python, and we will step through each of these uh, steps involved in the sign test. So in this particular problem, we have a case where someone is looking for apartment, and the median rental is 700. Now you as a parent, you would like to find out if that rental is really 700 or not in that area. So we're going to take the random sample data. Let's say, this is the rental here. And then with this series of rental values, we're going to compare the 700, keeping 700 as median. So let's see the Python code for this particular problem. Okay, so this is the Python code for the problem that we just looked at here. Just a second. So this is the same problem that I just showed you. And for this problem, the solution is here. So given the data series and the target is your target value of 700 and the alpha is 5%. And the package is SciPy here, and I'm also going to use binomial. I'm going to show you why binomial function or distribution is used in this particular case. So the null hypothesis is the median of the data is same as 700. So that's the null hypothesis. The alternate hypothesis is the median of data is not same as 700. So what we're going to do now, first find out the directions here. So wherever the value is greater than 700, we just find that out. So true means the values are more than 700. So we need to just find out that first. So wherever the greater than, that's the greater count. Wherever it is less than the 700 target, that would be a less count. So just so we have these two values, greater count and a less count, 18 and a 2. So this count is the number of values greater than the median and number of values lesser than the median. So T statistic is going to be, or rather the test statistic is going to be the minimum of the two. And so we filter out wherever we have zero cases. I don't think we have any zero cases here. So if there are any zero cases, then we just filter out zero cases. The number of data points after filtering, let's take a look at it. 20 is the number of samples after filtering. The parameter for the binomial distribution, now this is where the binomial distribution we'll be using. Now, in this case, we are looking at the probability of observing positive and negative randomly, like, equal chance of observing positive and negative, instances. So we take the probability as 0.5. Now we're going to take a range of values, like number of successes. Number of successes cannot exceed 20. So we're going to take that 0 to 20. And then we have a probability mass function for each of the values, which is basically the number of successes, like 0, 1, 2, 3, 4. And that's the binomial distribution. So essentially the binomial distribution is the probabilities for each of these successes here. So these are the probabilities of each of the successes. Now what we're going to do is find out the critical values from the binomial distribution using the alpha on one side and then 1 minus alpha by 2 on the other side. Since this is going to be a two-tailed, so we will have a critical value lower and upper. And after that, we just plot the binomial probabilities, PMF, and then we show the test statistic in the plot. So essentially, this is how the things look like. The shaded or the colored region in pink on both the sides are the areas where the rejection region will fall. That means your test statistic falls in the red or pink area. That means you can reject the null hypothesis. So the same computation you can do here using the cumulative density function and the test statistic that we just computed, which is basically 2, and that's going to return the value here 0.0000 something, and this is way less than the 0.05 as the threshold, and so we can reject the null hypothesis. So the outcome is we're going to reject the null hypothesis. So what is the null hypothesis here? The median of the data series is same as 700. That we are rejecting. That means it's not same as 700. So that's one example here of a sign test. Let's look at another example. And that example is in the second slide here. And let me read out the problem statement. So here we're talking about a professor believes that a new online teaching method is actually helping increase the median score. So now it's about finding out if the new teaching method is indeed improving the performance of the students. So the data collected is this, and the previous year performance was 75. So we need to find out if the given data is more than 75. Now here also we can use sign test because the data is not normally distributed. So the median value is 75 and the alternate is greater than 75. So SciPy, and again we're going to use binomial, and this is my data series. And after that, we just find out the greater than 75 and less than 75 and the equal to counts. And you notice here, I got about 8 instances of greater, 3 instances of less, 1 instances of equal, and total number of samples is 11. So now between the two, we pick the minimum of the two. And that's the test statistic. And then we find out the n, for the n, the binomial PPF, and that's the critical value for 5% range. And then the binomial distribution we use to get the probability mass function for all the values starting from 0 to n. And we plot that here. And you notice this is your rejection area, and this is my critical region, the red dots, and this is my rejection area. So any value which falls in the rejection region will be a candidate for rejection. So we look at the p-value 0.11, which is not less than 0.5. So we will not be able to reject the null hypothesis. And the output is, or conclusion is, you will not be able to reject. So that means at 5% significance level, we do not have evidence to support that support the claim that there is statistically significant difference in the final scores because of the new online teaching method. So with these two examples, I hope it is clear how to use sign tests and how to put together the problem statement and solve it using SciPy package. So let's summarize some of the key points regarding the sign test. The types of sign tests, we talked about two types. We have looked at the Python implementation for both of these. One is a one sample, where you have one sample and you are going to compare the median of a single sample data set against a given median value. Or you have a paired sample set and you would like to compare the median of both the pairs. So let's compare the sign test versus t-test. The distribution in case of a t-test is we have a normal distribution or data is normally distributed. Sign test does not have any such assumption. Sign test considers only direction. T-test considers both direction and the magnitude. An appropriate data sign test can be used with ordinal data, which is not the case with t-test. T-test requires data to be continuous and or interval or ratio type of data. And applications of sign tests when the data is not normally distributed or you have some doubt about the distribution or you think there are some outliers in the data, a skewed representation of data, then consider sign test. T-test is a perfect choice when you have a parametric situation. That means you're normally distributed. Even if it is slightly less normally distributed, then also t-test would be a perfect choice. And the t-test uses means instead of the median. So that's pretty much on sign tests. We'll continue with the more inferential techniques in the next video. Thanks for watching. See you.